Welcome everyone to today's PASS virtual chapter for the Database Administration Group. Welcome. We thank you for taking your time out of your busy day to join us here. Today our topic is going to be filtered statistics, and we're going to be listening to Susantha today. And once again, my name is Mike, and I will be the moderator today. So one of the things that we do here as part of PASS is an education center for everything SQL Server and Microsoft. And
Hey,
so,
Mike.
yes.
I'm just seeing the opening screen. I'm not seeing any of the slide deck.
Okay, I advanced the slides. Let's see.
Are you sharing your screen?
Yes, I am. The whole main screen. Let's see. Can you see the slide now?
Yes, I do.
Okay, thank you. I think I had that issue once before, but all right. So anyway, so today we wanted to talk about go over some things part of the PASS organization. So there's a Business Analytics Day, which is, there's two this year, one in Atlanta coming up next week, and one in San Diego, which is beautiful California. Full disclosure here, I do live in California. But you can actually go and here get expert training for only $5.95 a day. If you're interested in that, you can contact Tarisha Chung and also refer someone and get a discount on the administration. It's a great time. I've been to one of those, and they're very good sessions. The pinnacle of all the training that we do here at PASS is the actual PASS Summit, and it's an annual event. It's in Seattle again this year. It's the last day in October, basically October 31st and November 3rd. I've been to about 9 of these, and they're actually well worth the time and the effort and the cost, and the time away from work. It allows you to pick up a lot of good training and insight, as well as to network and connect with other folks in the SQL Server and community. It's a great time. If you register now, you actually get a discount if you use the VC code here that I'm highlighting on it's bolded on the screen. And so if you have any information, if you want additional information on that, if you go to passsummit.com, you can register and read up all the sessions, topics, and who's going to speak, and so forth. Even at that site, they also have some information on how to present it to your local organization to increase your chances of being able to participate. That's a lot of good material there just about the session, as well as how to present it to your management to let them have you come and attend. Like this virtual chapter, actually today we are part of a virtual chapter of many virtual chapters. There are many different topics and variety, from hardware, infrastructure, VC, to business intelligence, to a global kind of a thing, a localization. There's Italian, there's Hebrew, there's Russian, Spanish, big data, whatever you want. There's many different topics for further specialization under the PASS virtual chapter umbrella. One of the other trainings that we have is a SQL Saturday. It's a local event. It's an all-day Saturday event, and if you go to SQLSaturday.com, you can see all the upcoming ones, which you can see the current ones on the screen here. But if you go to SQLSaturday.com, you can actually go to, say, the Houston SQL Saturdays coming up this weekend. A good way to spend Father's Day weekend, by the way, is to go to a SQL Saturday. And if you go to that session, you go to Houston, click on the Houston location under SQLSaturday.com, you can actually see all the topics and the tracks that are going on. And that's true for all of them. So it's world based. So there's some in U.S., EMEA, Latin America, as well as APAC. APAC's a little bit empty right now, but they usually have stuff coming up. But that's a local thing. So if you can't make it to, say, SQL PASS Summit rather in Seattle, you could probably catch up with a local one. I have a friend that's speaking at the double one this weekend. He left yesterday, so that's a good time. There's also physical chapters. So I actually live in Silicon Valley, and so I go to the local Silicon Valley user group that meets at the Microsoft campus. But most likely there's one relatively close to you as well. And it's a great time to go and see folks face to face. You kind of talk to them about real life stuff, and get to know local folks as well. If there's not one that's near you, you might want to consider starting one up and establishing one and getting to meet folks locally that actually have the same mindset and bent towards SQL Server databases. Now, PASS is a large organization and it is volunteer run. And so if you're interested in lending a hand to help the organization succeed, then please go to SQLPass.org and say, I would like to volunteer, and we will put you in contact with someone to help use your skills in any way possible. Again, it's well worth the time that's put in. And there are some of you that just have come across SQL Pass, our content on YouTube itself. If you want to register at SQLPass.org, it is free, and then you'll be able to get updates on a lot of current stuff that's coming in and available to you versus just kind of searching on YouTube. That's a good way to do it. But if you want to get more information and plugged in a more organized manner, go to SQLPass.org and register. It costs nothing. And again, just connect with PASS to kind of be a part of a great community. So to our topic of today, we are going to be chatting about filtered indexes. Susantha is a Microsoft certified DB professional. He's been working with the coolest database on the planet, Microsoft SQL Server. He's been involved in IT for more than 16 years, 10 of which has been in a DB environment. He specializes in query optimization, admin and troubleshooting, and replication. He's also writes for a lot of the SQL Server sites that we all search when we're doing homework. So with that, we are excited today to turn the session over to Susantha. And with that, Susantha, I will make you presenter.
Okay, Mike. Can you see my screen, Mike?
Yes, I can see it.
Okay, good. Okay, welcome everyone. So I'm going to start my presentation. Okay, all right. So today's topic is about filtered statistics. However, I later changed my title to how to fix cardinality estimation anomalies because that's the objective of this presentation. So at the end of this presentation, you will be able to fix whatever the cardinality estimation errors or anomalies that you guys are having in different environments. So let's start. So about me, I think Mike already explained that. So this is today's agenda. What is filtered stats and how to create and how to use it and benefits. Okay, what is filtered statistics? So filtered statistics is introduced in SQL Server 2008, and it creates only for the subset of data. So which means, let's say if you have a column like this, and you have data in this column, so many data, and we call it as a domain, that is series of values which has the common attributes. And the filtered statistics is applied only for specific set of data, not the entire data set. So you can apply the filtered statistics here. So if you create, let's say if you create an index, it will apply for the entire data set for the domain. But if you create a filtered statistics or filtered index, we have another thing. So it will always apply for the subset of data. So depending on the predicate that you specify when you are creating index, filtered index or filtered statistics. So how to create it? Okay, there are two ways. So you can use the create statistics command, and you can create the filtered statistics like that. Only thing is you need to specify here the filter predicate. So in this case, where email promotion is equal to 2. So then your statistics is created only for the data that satisfies this predicate. And the second method of creating filtered statistics is to create the filtered index. And there also you can specify your predicate where end date is not null. In that case, it will select only that particular subset of data which satisfies this predicate. So either way, you can create the filtered statistics. So when you create the filtered index, it will also create the filtered statistics behind in the background. And you can also automatically, so manually create the filtered statistics by using create statistics statement. So either way is possible. Okay, let's flip over to our demo. So we have more demo time today than the presentation PowerPoint slides. Is this card? Right. This is my demo. Okay, so here hope you guys can see the font size and everything is okay. I already maximized it. The environment I'm using today is Microsoft SQL Server 2016 SP1 CU2. So why I'm specifying this environment is because I'm using some specific features applies only for this particular version. Actually for CU2, SQL 2016 SP1 and CU2. So make sure you get that similar version. Otherwise, you won't be able to use all the features, but most of the features will also work for previous releases of SQL Server. So you can actually create a new database, which is an optional step for this demo. I already created this database, which is called skewed data DB. It's already created, so I'm not going to create it because I can save more time. So I'm going to use that database, which I already created. And the next step is to create a table, specific table called big table. And it has big table ID, which is the primary key, and also has 3 integer columns, ID1, ID2, and ID3. This table also I created already to save the time. And the next step is to load the initial data set for this table. So there's a link I provided in the PowerPoint presentation under the references. So you can use that link to this to get this text file downloaded into your machine and put it in a directory, and then use this bulk insert command to populate this big table data. So it actually has about 9 million records. So it's a very big data set. So you can populate that. Also, I forgot to mention one thing here. After creating the database, I'm making the recovery to simple because while loading this data so that I can manage the transaction log properly. So that's why I'm making it recovery simple. Okay, so after loading this initial data to the table, what I'm going to do is I'm going to insert the same data set again and again 2 times. This go to means this statement executes twice. So it will execute, get the data set again and again and insert twice. The reason is I wanted to make some more duplicate data and to create some skewed data set. Then I can show the behavior of the filtered statistics properly. So you can do these things. I already done that to save time. For the verification, okay, I have this table created. It's already populated with the data. So I'm going to check the row count of this table to make sure it's there. Yes. So table has about more than 38 million rows. More than 38 million rows here. All right. And I'm going to do some more verification of this database to check the compatibility level. It's 130. That means it's SQL Server 2016 compatibility level. And I'm also going to check the legacy cardinality estimation value. I mean the value of this setting. This is the new setting introduced in SQL Server 2016. So legacy cardinality estimation is 0, which means it uses the legacy, new model. But actually it doesn't has any impact on statistics behavior, whether you use the legacy model or new model. So I'm going to use top 10 rows of this table to see how the data looks like. So it's basically all integers. However, the same principles applies to the text fields also. Just to explain it easier, I have used all these integer fields. So the first column is the PK. This is the primary key, auto increment primary key. And you have ID1, ID2, ID3, three columns. So we are going to focus on the values of the ID1 column today. All right. Then I'm going to check the statistics by using this SP help stats system stored procedure of this table. All right. So I already have primary key created. So primary key also has a statistics in the background. And also I have a non-clustered index IX ID1 for the column ID1. I already created that index. Otherwise, if you are following these steps from the beginning, you can create the index right here. Since it's taking time because it has a large volume of data, I already created that too. All right, now let's start with our sample queries here. So you can see in these there are three queries here, and there's a predicate where ID1 equals some value, ID1, and this value is different from query to query. So three queries, I have three different values. And also I have some query trace on options 3604, query trace on 9204. So these trace options 3604 actually uses to print output of this 9204 query trace on query trace flag into the console. However, I realized this 9204 trace flag is no more working in SQL 2016, but it has been working in previous releases. If you are using previous releases, you can check this. What this actually does is this will give you the stats header that query optimizer is interested and loaded into the system. So you can see what are the stats that query optimizer is interested for this query. So to see that, you can use this option, but in this version, this has no impact. So I'm going to execute these all three queries at once. So it's a very trivial query, which one condition and one table. And I'm going to enable actual query execution plan. So let's execute this. All right, executed. So you already can see here, the first query returns no records. Second query returns 4 records. Third one returns let's see, it returns actually 23,912 records. So very big number there. So let's focus on the execution plan. So you can see the execution plan is very similar in all three cases, right? It's index seek operations and key lookup, index seek, key lookup, index seek, key lookup. So only difference here is, so you can see some thicker arrows right here in the third query, because this query output 23,000 odd records. That's why these arrows are thicker. So it basically represents the data flow. So that's the difference. But otherwise, the plan shape is identical. Now let's look at the additional properties of index seek operations. So in the first query, so you can see the actual number of rows is 0. Estimated number of rows is 654.862. You need to remember this number, 654. So actual 0, the estimated number of rows is 654, which means when creating the execution plan, SQL Server Query Optimizer has estimated this query will return 654 records. But in actual scenario, it returns 0 records. So let's do the same thing for the second query right here. Actual number of rows 4, we have seen earlier. Estimated number of rows, again 654.862, same as the previous one. So SQL Server Query Optimizer has estimated 654 records during the query execution plan creation, but actually it does return only 4 records. Right. Let's focus the third query. The third query, of course, you have seen it returns a lot of records. Okay, let's get the properties of the index seek operator. Here, actual number of rows, you can see 23,912 records. What is the estimated number of rows? 654.862. Same. So in the all these three queries, estimated number of rows is same, 654.862. But in the third query, you can see the gap between the actual number of rows and the estimated number of rows is huge. Is that because stats is outdated? No. So we have just created the stats. I mean, I have created earlier, but haven't done any changes after that. No new data has been inserted or deleted. So basically the stats is brand new. But still we have gap between estimated number of rows and actual number of rows. And you know, this is not a good scenario, because the cardinality estimation needs to be really close to the actual number of rows returned. Then only your query plan is effective or efficient. So in this case, this plan is not efficient. But first and second, the gap is not much. I mean, compared to the third one, still there's a gap, but it's not much compared to the third one. So third one is really bad, I should say. So all three queries mentioned above have the same estimated number of rows. You have seen that because all three literals fall in the same step range. Okay, let's look at that. So you have seen it has used the index IXID1 in the execution plan. If not, you can see that now. Right here, it says what is the index it has been used. Okay. So now I'm going to check the histogram. So I need to tell you here, I'm not going to explain how Query Optimizer is using the histogram to calculate the cardinality estimation in detail. This is only focusing only for this scenario. So you maybe need to, read or watch some videos on how to, how actually SQL Server uses histogram to calculate the cardinality estimation in different scenarios. So I'm not going to do it in detail here because that's not the objective of this presentation. So I'm going to check the stats histogram of this index. Okay, here it is. So can you remember the where condition values that we have used? Okay, we have used 3882 for the first query and 38968 for the second query, and for the third query 9744. These are the predicate values that we have used in all these three queries. Now if you check these three values, so you can notice all these three values are false within these two steps, right? 3881, 43551. Actually this range high key is basically the column 1, ID1, because we are seeing the statistics created for that column. And all these three values are false within this two-step range, 3881, 43551. And also you can see what is the average range rows between these two steps, 654.862. Can you remember this value? So this is the value we have seen in these previous executions plan, all three execution plans, as estimated number of rows. So basically, the Query Optimizer has used this histogram to calculate the estimated number of rows for the literals or predicates that we have used in the queries. Not only these three predicates, if you use any value between these two, you will get the same row count as the estimated number of rows. So actually, you can calculate this value by using the same values in this histogram. You can actually do that by using the equal number of rows and then divide by 232 distinct range rows. Then you will get the average range rows. Okay, that's a bit of extra information. Right, now you know how SQL Server Query Optimizer has calculated 654.862 value for the estimated number of row count. So there's another DMV called DMDB stats histogram, which is introduced in SQL 2016's SP1CU2. So you can use this DMV to see the same histogram information that we have seen earlier. So you have two options to see the histogram. One is in the earlier cases, we have used dbcc show statistics command, which is available in all previous versions of SQL Server. And starting from 2016 SP1 CU2, now you have the new DMV to see the same information. So you have to pass two parameters, object ID and the stat ID. Then you will get that information. Let's see that. So what is the advantage of this? So it's the same information right here. So advantage is you can do additional programming or additional analysis by using this histogram and joining with other DMVs or joining with some tables created by you, contains different data to do some further analysis. So I also have created such a kind of a scenario. I will show you that at the end of this demo. Right. So now, okay, we know there's a problem now. What is the problem? Estimated number of rows that is given by the execution plan is way off with the actual number of rows returned. So there's a problem because we need these two numbers to get closer as much as possible. So let's do one thing. Let's try to analyze the actual data set between those two steps that I have mentioned in the histogram. This step 3881 43551 of this column. Let's do that. What I'm going to do in this query is I'm going to group by with ID1, which is the column name, and count all to see how many actual records are there for each value of ID underscore 1 column between these two range. So let's do that. Right. So now you can see here it returns 232 rows. 232 rows. So basically what it means is between that two steps, 3882 and 43551, between these two steps you have 232 distinct values for ID1. Distinct values because we are group by. We are making a group by for ID1, which obviously gives you distinct values for ID1. And this result set is ordered by descending order for the number of rows output. So highest value is 232, 23,912 records for this ID value. That is the highest number of rows, which we have seen in our third query also. 9744 is the literal in a where clause. So that is why it actually returns 23,912 records. Now let's go bottom and see what is the minimum value for that. Minimum row count. So minimum row count is 4. That is for the value 38968. So maximum is 23,912. Minimum row count is 4. Between 3881, 43551 of ID1 column. So look at the gap. So we have this much higher row count for some values and this much row count less minimum row count for some value. So there's a huge gap between these two. However, query optimize of SQL Server assumes between these two range, you have only 644, 862 average records, which is obviously incorrect, right? Because there's a huge gap. Cool. So do you guys have any questions? Are everybody on board, or anybody lost or something? Just let me know if you have any questions.
There's a couple questions. Excuse me.
Okay.
Do you recommend using multiple filtered stats? Is there any performance if you use more than one filter stats?
No, that's what I'm coming to actually. We can use multiple filtered stats. Actually, you can create them automatically also by analyzing the data distribution of your table. So there's no any overhead because it's to create stats. Stats is very lightweight, not like index. You can create on the fly and it takes very less time. Because the reason is, so you cannot control the data that is coming into your application, right? So data comes to your database has skewed data distribution. So you have no control over that. You cannot say, okay, this is skewed data. Hey, don't insert those data into my database because my queries will go wrong. Can you say that? No. So that is not controllable. However, what is controllable is you can identify those skewed data and inform the query optimizer, hey, in this area, you have some special data which needs to be treated differently. So that query optimizer has that information. So by creating filtered stats, that's what we are going to do. So creating many filtered stats is no harm than a good.
Okay.
Any other questions, Mike?
No.
Okay, cool. Right. So what is the estimated row count if you put any value for ID1 column between these two? Yes, I told you that. Excluding these boundary values, however. So you will get the average row count, right? That's what it does, 654. Doesn't matter what the value is. Between these two, any number you can give it and it will give you the same average number of row counts. But the actual number of row count is different. Okay, now it's time to create the filtered stats. However, we are going to, as I explained earlier, filtered stat is created only for the subset of your data, not the entire data set. Okay, so we know between these two steps, there's a problem because of the skewness of data. So I'm going to create a statistics object only for this range, right? So I'm specifying that range in this where clause. Let me give you a closer look. This where clause, I'm specifying this range 3881 and 43551. And also I'm using full scan. That means it's not a sample. So it does a full scan to identify these two ranges of data. So what is the advantage of, okay, you know, the histogram can have only 200 steps. Only 200 steps with the null value actually 201. No matter how big is your table, any histogram can have 201 steps maximum. So within these 200 steps, you have to somehow, you know, represent your actual data set. So it is kind of a really challenging job. So by using filtered stats, what we are going to do is we will get additional 200 steps, which means we are actually increasing the histogram 200 steps limitation, right? So let's flip over to my slide deck to give you more information. Okay, I'm not going to discuss this right now. However, this one. So this is actually the graphical representation of the actual data distribution. between these two steps for the column ID1, which I have showed you in the in that query, the select all query group by ID1 column. So this is the maximum row count, actual row count we have seen, and this is the minimum row count we have seen, and this is the mean that SQL Server uses as the estimated number of row counts between these two. Okay, and there's another thing we can calculate in statistical terms, which is standard deviation. Standard deviation actually means it's a measure of the dispersion of a data set from its mean. In other words, how spread out the values from the mean, or how distant your values from the mean. For example, I'll go into the other one. Let's say your mean is right here. This line represents the mean. And when you calculate the standard deviation comes to 2442 in statistical terms, which means you can deviate. The maximum that you can deviate from mean is the standard deviation value. That means this value. So it can go positive or negative. So any row count between this area is kind of accepted because it's within the standard deviation area. But any value beyond this standard deviation area, the more gap from the mean to the row count of your value is bad. That means the more away the values from the mean, the more inaccurate your cardinality estimation is. That's why in the third query, 23,912 records is the actual, whereas the mean is right here. See how much is the gap? How many standard deviation is the gap here? It's huge. So which is bad. Cool. So, okay, I haven't created the filtered stats yet. I'm going to create it. See, it's just created. It's even less than 1 second. Now I'm going to check the statistics again. Okay. This is the stats we created right now for this column. New stats is created, verified. Now I'm going to check the same query again. I'm going to execute the same query. You can see same predicate here. And second query, same predicate as the earlier one. Third query, same predicate again as the earlier one. No difference. I'm going to execute. And the query execution plan is enabled. Execute. Now the only difference we made is created the filtered stats. Number of rows output is same in all the queries as previous because we haven't made any changes to the data set. Okay. Execution plan also same. Plan shape is same. Index seek and key lookup, no difference there. Let's look at the properties of the index seek. Okay. Actual number of rows, 1 first query. Estimated number of rows, 1. Look at the difference. In earlier case, we got 654.862 here. Now we have 1. Actual 0, estimated 1, very close. Very good. Second one, again, number of rows returned, 4. Estimated number of rows, 4. exactly close, exactly similar. Earlier we got 654.862 here. Now estimated and actuals are same. Really good. Third one, which is our concern because the gap was huge in earlier case. Actual number of rows 23,912. Estimated number of rows 23,912. Exactly same, no gap, so we all good. So after creating the statistics, filtered statistics, we have made dramatical change or improvement. Actual versus estimate is similar now. How that happened? Okay, let's look at the histogram of the newly created stats. Sorry, I clicked the wrong button. Okay, now you can see here. What is our first value? 3881. Sorry, 3882. Let's navigate the histogram. 3882 is not there. If anything is not there in the histogram, it assumes as 1. That's why it gives estimated number of rows is as 1, but actual 0. Because SQL Server assumes if it is not there in the histogram, it is 1. So how about the second value? Second value is 38968. Let's look at the histogram. 38968, somewhere below that. Okay, through here. 38968, somewhere here. Okay, 38968. Okay, this is the actual number of, sorry, estimated number of rows. Equal number of, this column is actually equal rows, which means number of equal rows for this value is 4. That is where the SQL Server query optimizer has taken as estimated number of rows. What is the other value? We have the third predicate, 9744. If you are seeing 9744, 9744 is right here. Equal number of rows 23,912. This is actually the estimate, but actual also same. So now the step range in the earlier histogram without the filtered stats, we have broken into very detailed histogram so that individual values can be looked into in the histogram directly. That's why the filtered stats improve the cardinality estimation. Okay, now we know how to fix that. Okay, cardinality estimation errors. By using the filtered stats, we can do it. But the question is, how do we analyze this kind of a data set? How do we know in which area we have this problem in our data set? It's a problem, right? Okay, so before moving to that, do you have any questions, Mike?
One that's similar. Do you?
Okay.
It's again about the performance. If you have multiple filter statistics, will that have an impact with auto update statistics?
No, it doesn't have impact, because when you create this filtered stats, it is explicitly created stats by the user. Only thing you need to worry is you need to maintain that, because SQL Server will not maintain it because it's created by the user. Because if you have stats attached to the index, when you reorganize or rebuild the index, the stats also will be taken care of. But when you create the statistics only, explicit statistics, then you need to maintain it. That is the only thing you need to worry about.
I see.
Okay.
Okay, thank you.
Okay, no worries. Okay, let's Move on to our presentation. Okay, what is the benefit? Benefit is to improve the cardinality estimate. That means estimated number of row count is more close to the actual number of row counts, which is what we want. The second benefit is a workaround to remove the histogram limitation. As I said, histogram has only 200 steps, but creating additional statistics for the same column only for the subset of data, you can actually increase. You will get another 200 additional steps. So by that way, you can actually increase the number of steps for the histogram for the same column. And this is the summary. With no filtered statistics, these are the predicates that we have used in all these three queries. And all these three cases, with no filtered stats, we got the same estimated number of row count. And this is the actual number of row count, just to give you the comparison. And after creating the filtered stats, this is the estimated number of row count, actual number of row count. Very similar. Okay, let's go into the demo. Right. So I didn't tell you how to analyze that. I have created a stored procedure. Again, you can download this stored procedure in my GitHub repository. It's given in the presentation as well, in the demo scripts too. So I'm going to share this after this presentation. So here you need to pass two parameters, your table name and the statistics ID. So in this case, my statistics ID is 2. That means for the clustered index, sorry, non-clustered index, not the filtered stats. Okay, I'm going to check that. Analyzing the skewed data. I will show you the contents of this SP in a minute. Okay. This will actually go through the statistics object you have mentioned as a parameter in the to the stored procedure, and going through all the steps and calculate the mean for each step, mean value, and standard deviation, and the variation. Variation is how much distance from the mean. If the distance is too much, then those are the places you need to address. Okay. So actually the step range that we looked into is this one. Step number 2, 3881, 43551. And you have seen between these two steps, you have seen 232 distinct rows. And the average range rows is 654.862. This is I have taken from the histogram itself. But this value I calculated, it is almost same, but I'm just omit the decimal part. And standard deviation also I calculated between these two steps. And then I calculate the variance. Variance is how much or how distant or how far from the mean. If it is too far means again you have to decide that whether it is 300, if the value is above 200 or something, you have to taken care of. So I have just spotted this one. Actually, these also, it has higher variation than this one. So these are the steps that you need to create your filtered stats. But from up to which point is basically we need to decide it. Okay. And if you analyze the variance for the new filtered stat that we created, let's do that as well. That filtered the stat ID is 3, and you can see that. So it calculate this information for all the steps mentioned in that stat. Now you can see variance is below 50 in all cases. Null means actually it doesn't, it has only one single value. So there's no, if it is single value, no point of calculating, because standard deviation, mean, and everything is for multiple values. If you have single value, then we cannot talk about standard deviation or mean. So if you have multiple values, these are the places and this is the variance, and you can see compared to the above the previous stat object, the variance has reduced now below 50, which is really good. That's it, and I can show you this. Give me a minute to show you this script contents. Again, you can download this script in the GitHub repository. It's there. I'm just gonna. So here, what I'm going to what I'm using is the new DMV. DMV DB stats histogram, because it's easier than the DB CC command, because it's a table output. So you can straight away join. I'm joining the same histogram views as two different aliases, which means two different views, because I need to get these two steps in single line. That's what I'm doing it. So I'm doing a cross apply here to calculate the average, mean, max, and standard deviation for each and every steps. I'm going through each and every steps to calculate that, and order by variance, and this is it. So you can identify for basically analyze the entire data set of a table related to stat object, then identify skewed data distribution. This will go through the entire data set. So please be careful when you are executing this against production databases. Just execute it in a different environment for, I mean, if you have a large data set, because it scans through the actual data set, might create some problems if you run it in a busy time. So let's flick back to the, okay, these are the references. Download the data set. Data set also you can download. Here's the link, same link. You can have the data set as well as the stored procedure. All right, that's it I have for the presentation today. Any final Q&As?
Well, thank you, Susanta. I appreciate that. That's we have big gaps like this in our location here, and so a table with 1 billion rows in it that I've been looking at doing this, running filter statistics on to kind of help some of the data skew.
Yeah,
only
exactly.
Only having a couple hundred buckets for billions of rows is
right. Sure.
There's always a challenge. But yeah,
Right.
but with that, I'd like to thank you for today's presentation. It was very good.
No worries.
And I want to thank everyone else for attending today and paying attention and asking great questions. And we look forward to seeing you on July 26th on our next meeting. Thank you very much.
Sure. And thank you, everyone. And thanks, Mike, for doing all the coordination work.
All right.
Thank you very much.
Thank you, everyone.